Hello TCMS, this is Mrs. Martin here today with your Unit 3 Combinatorics Practice Quiz Review. Now before we get started, I just wanted to mention the update I posted on Schoology last night. If you haven't seen it or read it already, please go back and do so. I know it's kind of long and I'm sorry that it's so wordy, but it was a lot of information that I wanted to make sure you got. So please know that when I post updates, I really do try to make them as short as possible so it's not taking up too much of your time. But if you haven't done so, again, please go back and read it because pretty much what it's saying is the next 2 weeks of ALEKS goals will be optional. Okay, and that's in honor of the AP exams. A lot of people are stressing about the AP exams because they were not what they were expecting for this school year. They're going to be very different than the usual. And so I know a lot of you are stressed about that. And so to kind of alleviate some of the stress, I decided that I would make the ALEKS time and topic goals for the next 2 weeks optional, okay? With that being said, I do want to remind you that our ultimate goal for our ALEKS pie chart is at least 80%, which I know a lot of you are already there. So feel free to continue working on your ALEKS time and topic goals. Also, because I plan to give any of you who still work on those time and topic goals some extra points, okay? So I know that this quarantine has made it very difficult to complete some of our assignments, and some of us have missed those time and topic goals due to different circumstances. So if you were missing any of your time and topic goals from before, this is a great opportunity to earn back some points if you missed any. So again, ALEKS goals, next 2 weeks, optional, but please take advantage of getting some extra points if you need them. And then if you're really trying to prepare yourself for your AP exams, feel free to take the time to do that. Okay, so let's go ahead and start our Unit 3 Combinatorics review. So what I've done here is I've made a slideshow covering the material from the Unit 3 practice tests or practice quizzes for lessons 1 and 2, which is the material that we've covered over the past couple of weeks. And what I did was those of you who submitted by about, I would say maybe 3 or 4 o'clock yesterday, thank you for doing that because I was able to see your work. And a lot of you did some incredible things on paper and submitted those. So I was able to screen capture those and add those to the slideshow in order to share with you. I wish we could have done like we did in class where we had the group share out, but since it is very hard for us to get online and meet with each other, I get it. And so I would hope it's okay that I just borrowed your work. Okay, it is anonymous, so again, thank you for contributing to our class's learning. Okay, so lots of videos that you guys have been watching. I hope that they're helpful. I hope that being able to pause and rewind has been something that is useful for class and useful for lecture. I also hope that you've been taking some time to do a few notes. If you haven't, I would make at least a reference sheet for yourself before you start quiz number 3 so that you have those formulas available to you. Remember, you're always allowed to use your work, you're always allowed to use your notes because the quiz materials always contain new questions. So it's all reference material, right? For this slideshow, I've included this slideshow with the YouTube link on Schoology in case you're subscribed to the channel and you're just watching the videos as they're posted. Check out the slides in Schoology if you would like to go back and look a little more closely at some of your classmates' work in order to support you through the rest of Unit 3. Also, if you have any other questions, when I post these videos on Schoology, I again ask that you ask those questions in the discussion. A lot of you tell me that you watched it and you let me know that it was helpful, and I really appreciate that feedback because it gives me the motivation to keep going. But again, if you have questions about some things, feel free to post those there as well because I think they would be very helpful to your classmates. I'll be able to look at your posts, respond to your posts, and then hopefully it kind of helps us with our learning. Okay, and then finally, please make sure you stay tuned to the end of the video. I'll be going over the quiz very briefly as far as how to upload especially one part for your tree diagram. So you're going to want to kind of look into that. So again, some tips at the end of the video about the Schoology quiz number 3. All right. So moving on, we are on lesson 1, question 1, and that's the question about the Quick Stop Cafe, where we had a meal to order, a breakfast meal to order, where we had 3 types of egg options. We had 2 meat options, bacon or sausage, and we had some bread options, whole wheat or white toast. Okay, and so assuming that the person ordering wants eggs and a meat option and a bread option, we wanted to try and create a tree diagram that shows all possible breakfasts. And so here are some examples from some of your classmates who did a really great job of showing the tree diagram. Now, a lot of you have become very proficient with the tree diagram, and I was very happy with the work that was submitted as of yesterday. This person I selected because they showed with color. This is not necessary, but I thought it was kind of cool for you guys to see. They used colors to show the count of each option and kind of going through the branches of the tree. So that was kind of cool to again show there were 12 options. This person color coded in a way to show the categories. So we had the blue egg category, the pink meat category, and the purple bread category. So that was kind of helpful to see how things were different. This person also made a tree, again using colors to show the count of all the options. And then finally, another very nicely organized tree that really helps to show how many different options are available for this breakfast menu. Okay, so as long as you're making sure to keep with the categories and having each grouping or each category make a level of branches for your tree, you'll be good to go making your tree diagrams. And these are examples of tree diagrams that would definitely earn themselves full points on the quiz. Okay, moving on to question 1B. Again, sorry, I know it always says like 3 questions and it has a billion parts. So part B asks, how many different breakfasts are possible and how is that shown in your tree diagram? So most of you utilize a tree diagram by just counting as shown in the last one, but some of you went ahead and talked about the multiplication principle. Okay, and that kind of comes in part C, but this person really outlined what the 3 represented, what the 2 represented, both 2s. Okay. They talk about the breakdown and the 12 possible breakfasts. So pretty much they use their tree to give an answer. For part 1C, then we're getting into the multiplication principle. Now I selected this one because I really like, it wasn't the full multiplication principle of counting, but it was a really cool way of combining lists and multiplication. So this person start with the fried eggs in blue, and then they showed bacon and sausage in green, and then they showed whole wheat bread and white toast. Say whole wheat bread and white toast in red here. And so he understood that those were 4 different options given fried eggs, and knowing that there were 3 types of eggs that were available, he multiplied by 3 and got 12. So I thought this just was a really cool way of showing the list combined with the multiplication principle. So if you are showing work for your multiplication principle of counting, this is a very good comprehensive way of showing that you know what you're doing when you use the multiplication principle. Okay, here's another example of someone else's work. They showed the number of options, which was nice for each category, and then they took those numbers and multiplied it together, and they really showed all the levels and all the work, which was nice. I can really tell what's going on with this work. This person did similarly. She included the units to get the 12 different breakfast combos. And this person, I like this person's work because he color coded the numbers here, blue for eggs, pink for meats, purple for toast, and then used those colors to show them in his multiplication down there at the bottom. Okay, so really great work with multiplication principle of counting. For part 1D, it asks to explain how the tree diagram and the multiplication principle of counting are connected. Now, this isn't a question that's going to be on the quiz. It's more of a thinking question for us to practice and talk about for homework. So I wasn't really going to go over it, but some of you had some really great responses, and here was one of them. The tree diagram in part A and C are connected because both methods are separated by the kind of options. For example, in the tree diagram, the first tier is egg, the second is meat, and the third is toast. In the same light, part C's first digit is egg, the next is meat, and the last is toast. I thought this was an awesome answer talking about the tiers or the levels of the tree diagram and comparing them to the integers that are used in the multiplication principle of counting. So again, don't expect this type of question on the quiz, but I did want to talk about a good answer to a question like this. And I'm sure a lot of you had really good answers and good connections made on your homework, but this is one that really stood out to me, so I wanted to make sure I shared it. Continuing on with question 2. Oh, here was another one. Here was one more before we move on. This person mentioned that the tree diagram and the multiplication principle of counting is the same thing, but tree diagram takes more time and effort. And I agree, especially when the numbers start getting pretty large. So just something to keep in mind. Tree diagrams are great because, again, they do show the same thing. But when time's of the essence, multiplication principle is probably the way to go. All right, so moving on to question 2. So again, we're still in lesson 1, and we're talking about question 2A. So in 2A, we're talking about license plate numbers, okay, and in Virginia, West Virginia. And I think we had a little trouble with all the information it was offering. It did have 3 things that were important to think about. And all that is hopefully in front of you as you're following along with this review video. And here's some work from some of your classmates. So how many possibilities are there for West Virginia license plates that have 3 AB for the first 3 characters? So pretty much what they're saying is, of the 6 characters, we've decided that the first 3 will be, the first one will be 3, the second one will be A, the third one will be B. Now, as for the next 3 characters, that's for us to figure out how many different combinations are possible. So a lot of you did a really great job of showing things that were set. So this person used blue to show that the 3AB was a set value. Okay, we had to pick those 3 because it was given to us in the problem. And then the last 3 were the ones that we weren't really, this is where we're trying to make the different possibilities, right? The different groupings for license plate numbers. And so one thing to remember for questions like these is that we have independence. And I know I talked about that in one of our videos. Independence meaning whatever I place here, here, or here, it doesn't matter for, it doesn't affect the outcome of the next 3. Sometimes that does make a difference for us. So they are independent. So looking through these, it is very tempting to put here because we have 0 to 9. And so it's kind of instinct to just say, okay, 9 values. But this person did a really great job of listing the values that can be placed in these boxes for the license plate. These are the different options I have for this box, this part of my license plate number. And so they counted those and gave 10, okay, 0 to 9. And so once I select a number for this 4th character of my license plate, then I move on to the 5th character, and I know that, again, because they are independent, it didn't matter. Like, for example, if I chose 1 here, it doesn't mean I can't have a 1 here, right? They could all 3 be 1s. And so since they are independent, and since, it doesn't matter what happened here, we still have 10 options here. We still have 10 options at the end. And again, that's because as part of our requirements in number 2, it says the last 3 characters are digits from 0 to 9. So that's where the 10 is coming from, okay, 0 to 9. And so this person showed that very clearly. And when they multiply the 3 down here, we're not really worried about these ones because those are set. But when we multiply the 3 back here, we get 1,000, okay? 1,000 license plates could be made in West Virginia with the numbers 3AB there at the back. Okay, the next person did something similar. Again, they used 3 boxes to represent the last 3 characters of our license plate, and again came up with 1,000 possibilities. And also, I just wanted to mention I appreciate so many of you writing your responses in complete sentences, not just writing 1,000, but including 1,000 what, right? 1,000 possibilities. So thank you for doing that. Question 2B asks, how many different license plates are possible in West Virginia altogether. Okay, so this time we don't care, we weren't given what the first three characters were. And so with that in mind, this person knows that we've got here 6 empty boxes now, again, because we weren't given anything for the first 3, like in part A. We know that in this first box, we have 0 to 9, I'm sorry, 1 to 9 as options, or the letters O, N, D. Okay, so thinking about that, that means we have 1 through 9, that's 9 options, plus O and D, that's 3 more options, which gives us the 12 choices. Okay, so that's where the 12 choices in this person's work is coming from. The rest of this is pretty straightforward. We've got 26 letters available for the second and the third, and then for the last 3, same thing we had in part A. Okay, we've got some pretty gnarly multiplication happening here, and notice how many license plate numbers are available to select in West Virginia. Okay, so we've got quite a bit there. This person did something similar. We've got boxes. They filled those boxes with the options they have in for each character. And again, they labeled their answer, which I appreciate. Same thing here. This person kind of showed their multiplication happening, which was nice. But again, ultimately, same answer. Okay, so thanks for labeling all your stuff. I thought that was great. It shows that you know why you're putting the numbers where you're putting them. And I think that's really important. So nice job here. Moving on to question 3. We're talking about getting 2-letter employee IDs. Okay, and they get 2 capital letters. And again, they are independent of each other, meaning if my first letter is an A, my second letter could very well be an A as well. Okay, it doesn't eliminate A as an option for the second letter. Okay, so repeats are allowed. Okay, and so with that in mind, we can use our multiplication principle again. And this person showed that very clearly. We have 26 letters available for the first one, 26 letters available for the second one, and they multiplied through. So nice job. Finally, question 3B, they ask if the company grew and then the owner decides, well, you know, I have more than 676 employees, so I'm going to need to make 4-letter ID badges instead of 2 letters. He assumes that he'll then have double the number of possible ID badges because we have double the letters, right? And so many of you were able to decide that he's wrong, because if you double the 676 from part A, you get 1,352, which this person shows here. Okay, so maybe if we had a 2 here, 2 times that, which is double, is 1,352. But they showed that if I've got 4 characters, there's 26 options here, 26 options here, so on and so forth. This is the number of ID badges that could be created. And that is significantly greater than double 676. So this person used math to clearly show that the person, the owner of the company, saying that it was double, it was actually way more than that, right? So thank you for showing this math. It does show why this assumption is wrong. So we're going to continue on here with lesson 2. I'm trying to go through this fairly quickly so you're not taking up too much time watching this video. And question 2 is about the Wilsons planting fruit trees in their yard. Now, this, there were a few words in this lesson. I had a few students ask to meet on Zoom to discuss the quiz. And we realized that some of the verbiage in lesson 2 made it kind of difficult to decide whether or not we should use a permutation or a combination. And I think for some of these, we disagree with what the textbook is expecting. But the answers that I selected from your work to share on the slideshow, I think represent this lesson 2 quiz the best. So if there's any questions about this, again, please feel free to post them in the discussion. But I made sure on the quiz to be try to be very clear about whether or not you should be using a permutation or a combination without, actually using those words. So let's try and continue this again. Sorry for the weird wording from your textbook, but I'm not 100% surprised that maybe they do that on purpose to really test your knowledge. So here's 1A. They decided they wanted to plant 3 different trees, and some of you went ahead and multiplied 7 times 6 times 5. So it would be the 7 trees available, and then after I plant one of those, and I really only have 6 available to plant for the second one because I wanted them to be different, and then the same for the last one, I would only have 5 available because I wanted them to be different from the other 2. And that would be fine if we were concerned with order. Now, since we're not concerned with order, that's why this person decided to go ahead and go with the formula for combinations. Okay, so that's what's happening here. Pretty much what we're saying is, let's say we've got lemon, apple, and cherry growing. I don't really care what order those lemon, apple, and cherries are being planted in. I just wanted to make sure that the trees were different. So that grouping of lemon, apple, cherry could be done 6 different ways, but it's still going to be the same group. So if you haven't seen the video about the committee where we're talking about combinations, please go back and check that out because it details a little more why we're dividing by this 3 factorial. Okay, and again, we're just compensating for all the different orders of the same group. And so since this question really specifically asks for different groupings, we can go ahead and go with combinations and conclude that we've got 35 different groupings of 3 different trees. Okay. Now for question 1B, this is where I think we had a few misconceptions about what exactly was being asked. A lot of you got the right answer, and you got the right answer using a permutation. But again, if we think about it, permutations take order into consideration, where we're worried about which one's being planted first and which one's being planted second. But in this scenario, where we were just trying to plant 2 types of trees, still 3 trees, but only 2 types. So for example, maybe 2 cherries and a lemon, or 2 apples and a grapevine. It doesn't matter what order those come in. And so since we're talking about something where order does not matter, then we're talking about a combination. Now, oddly enough, the permutation got the correct answer though. But I'm not sure, I'd have to try some more examples with you guys, and I'm not sure if that's going to happen all the time or if it just was a coincidence for this problem. So here is some of the work that many of you did, and it's beautiful work. The work with the permutation is perfect. The factorial is very clearly shown here. The work of how they've got, the formula being shown here was great. They mentioned 42 different groups of trees. But again, it's not necessarily a permutation because we don't care about the order. So just to look at this together quickly and make sure that we kind of have a better idea of what's happening, I'm going to go over this really quickly. So let's consider our little garden, and we've got 3 trees. Sorry, they're not beautiful. Okay, so here's my 3 trees, and I'm going to label these trees. I'm going to have an apple here, and I'm going to have a lemon here. So again, using a combination because order does not matter. And I've got 7 trees to choose from, and I need to choose 2. Now, when I use my formula for this, I get n at the top, k at the bottom, and then n minus k at the bottom. Okay, and I'll let you do some math on that because I think you guys have gotten very proficient with the factorials. I actually get 21. Now, the problem with this being the final answer is that this 21 represents the different options of 2 trees here. What about this guy, right? And so for this guy, we have 2 options. It could either be an apple, because this was no longer independent. Okay, and maybe this problem was looking for your understanding of independence. It's not dependent because I'm not allowed to pick whatever I want for the 3rd tree. It can only be 2 things. it can only be an apple or a lemon. And since I only have 2 options for the last one, I'm kind of implementing my multiplication principle of counting. Okay, where I'm going to end up with 21 times 2. Let me use the multiplication principle notation. So times 2. And that's how I get my 42 different groupings of trees. Okay, so again, we did happen to get 42 for the permutation work. And I'm not sure if that was coincidence or if that you guys just found another theorem or postulate that could be implemented into math. You might have. But for right now, just be aware that sometimes questions like these, we do have to very carefully take into consideration the fact that all the information that's given. So we could choose 2 from these 2, and then this one is no longer independent. Dependent on whatever this was. Since we have 2 options, we use our multiplication principle of counting. So great job doing the work, great job finding an answer, and it was actually the right answer, but make sure you're reading very, very carefully. Okay. So, and actually I think that was the only one that we kind of struggled with, so that's awesome. Let's keep going through this. Part C. Now, part C was really tricky for us when we were working on it in Zoom. And I was very impressed that you guys were able to find all this material for part 1C. Everybody got pretty much the same. I particularly liked the combination used in the middle here. They were able to use combinations here. And again, I'm not sure if that's coincidence, because usually for combinations, we can't have repeats. And in this case, we could have repeats because they don't care if they have to be different types. So lots of weird things happening with the combinatorics questions. And this particular quiz, like I said, was very tricky. Just to kind of go over where these numbers are coming from. So again, combination used here happened to get the right answer. And I'm not 100% sure if that was a coincidence or not, but just to review where these numbers came from, the 35 was from part A. So that's part A, okay? That was the situation where we had 3 different trees. This is coming from part B, the situation where we have 2 different trees. And this last one, the 7, some of you might be wondering where that comes from. And this is actually coming from all trees the same. Okay, so it is possible, same. So it is possible that your 7 trees, maybe you really, really like apples and you want all 3 trees to be apples because you only want to eat apples forever. So if you have 7 different options and you want all the trees to be the same, then you have 7 groups where all the trees are the same. So they made sure to account for those, and then they got 84. This was a particularly complicated question. And I was, again, very impressed that so many of you were able to deduce where all these numbers are coming from. So because of the complicated nature of this question, I don't plan to have a question like this on your quiz. As a matter of fact, it's not on there. I already posted the quiz. So no questions like this type on the quiz, because again, I'm just looking for your mastery of the standards. And this one is particularly critical thinking. So don't worry if this one's still a little fuzzy to you. This is a more complicated problem. But again, a lot of you did a really great job with them, so kudos. So let's keep going. Try to finish up this test. Now, question 2, again, I'm not posting question 2 on the quiz because this is more of a critical thinking homework discussion type of question than a quiz question for me. But since some of you answered it really, really awesome, I wanted to share some answers for question 2 on lesson 2. It said not to use the formula to explain why a permutation is always going to be greater than a combination. So this person's response was nice. They did mention dividing twice, just kind of referencing the function, but it does make sense. You know, we know what the equations look like, and just to kind of remind ourselves what those look like. For P, we've got n at the top, and we've got n minus k at the bottom. Now for C, we get what this person calls double division, okay? And what they mean is we've got the n minus k, but combinations include dividing by k factorial. Okay, and so that's what they're referring to as the double division, that extra one right there. And so of course, you know, when we divide things more, they get smaller. You know, think about a pie. If I divide a pie up really in a lot of pieces, and we all get a really small piece of pie. So dividing a lot makes things smaller. And so that's why permutations are going to be bigger. But again, the question did mention to try not to use the function. Now, I personally had a very difficult time explaining why P was greater than C without referencing the formula. I mean, the formula is here. It was a lot easier for me to just say, well, yeah, because you're dividing an extra time here. But the next person actually did manage to explain it in a way that I thought was pretty cool. So they said PNK is always greater than CNK, and choose K, sorry, because permutations are ordered combinations. If you take one combination and line it up or mix it up in different ways, you get more permutations. Combinations is just finding the number of groups. So pretty much a permutation, you're counting all the different orders. A combination, one group is sufficient. And so that's how they kind of explain why P is always greater than C. And I thought that was a really great explanation. So thank you for submitting that. I had to share, even though this is not really a question I'm going to put on the quiz, it was still a great response to your homework questions. All right, finally, we're almost done. We're at question 3 of lesson 2, where we're talking about Andrea's birthday sleepover. So again, here's another one that we didn't really agree with the textbook wording. Okay, so this person, they submitted their work. They circled the word ways in which they understood that order mattered, and that's why they used a permutation here. Okay, so this is more like the multiplication principle of counting, but she did mention down here that she used permutations in a way. We just eliminated the canceling out part here. So how many different ways can they choose the movies to watch? Now your book considered this a combination because they were just talking about the groupings of movies, but this vocabulary makes me say permutations and agree with this student. So watch out for wording. Again, this is what I meant about the lesson 2 verbiage. So if you went with the permutation here, I agree with that. It does feel like order matters when they say how many different ways can the movies be chosen. To use a combination, I probably would write something more like how many different groups of movies could be made. That might make me feel like order doesn't matter and I can go with the combination. So again, watch the wording. This one I would definitely go with permutation, although your book disagrees with me. And 3B says, okay, well, now that we've chosen 4 movies, we've all decided, now we want to try and make a schedule to watch 4 movies. And I don't know how this sleepover is managing to squish in 4 movies, unless you're staying up till like 5 a.m. But somehow they squish in 4 movies. They want to make a schedule. And so to show this schedule, they chose 4 movies, and then we use our multiplication principle. We can actually also use permutations here. It's a little weirder, but we can do it. Just to kind of show that before we finish up. We didn't really talk about this rule, but if I'm using a permutation, I've got 4 movies and I'm choosing 4 movies, okay? And I think that's where things get kind of weird. So I've got 4 factorial up here, 4 minus 4 factorial down here, and then we run into something really weird looking, a 0 factorial. Okay, and that's something we didn't talk about. And oddly enough, whether it's intuitive or not, 0 factorial is equal to 1. So Didn't talk about it. Doesn't seem really obvious that 0 factorial would equal to 1, but, and so ultimately we get 4 times 3 times 2 times 1 over 1, which is pretty much what this person got. Okay, so if this right here makes you scared, don't worry about using a permutation. It was only 4 movies, so you can definitely just go with your multiplication principle of counting to get an answer. And that's a wrap, everybody. We did it. All done with Unit 3. Thank you again for sticking with me on yet another video. I hope you're not getting sick of them, and I hope they're still being helpful, and you can find time to do them when you're ready for some learning. But let's talk about the quiz for a second. So again, lots of stuff happening with the quarantine, lots of stuff happening with AP tests, so on and so forth. TCMS is very strict about their one chance policy for the quizzes. And I didn't really get any feedback about retaking quizzes during this quarantine situation. And so to be safe and to make sure that your grade is honest and true, I'm not going to allow retakes on the quizzes because that's TCMS policy that has not been changed. Okay, so again, once you take this quiz, I want you to know that that's the grade you're earning on the quiz. So with that being said, I can be very flexible with schedule. Okay, that is in my power. So if you don't, I know the quiz is posted today, but if you don't feel ready to take it, don't take it yet, okay? Make sure that you feel thoroughly reviewed for the quiz before you take it, okay? And again, it's because you only get one shot for this quiz. So I would really highly recommend that you make sure you understand everything on the practice quiz. Make sure you really understand how to do the material from Alex and do the homework problems. If you haven't done those yet, make sure you submit all that and get my feedback so that you know you're doing everything right and you can move on. And then once you're not so stressed and once you feel really prepared and you're ready to go, then you can take the quiz, okay? And if you have any questions or you need any support, please feel free to reach out to me. The quiz is going to have a 24-hour time limit. Okay, so when you see it's going to have like 1,400 minutes on the bottom of your screen. That's just to make sure that once you start the test, you have to finish it within the day. Okay, I don't want you to open the test, check out all the questions, and spend the week practicing them. Okay, so you do have the day to complete the test. Okay, that means you can get up, take breaks, have snacks, eat breakfast, lunch, and dinner. But just make sure you sit down. I definitely don't think it'll take longer than an hour or two. It is a pretty short one, but I will give you the full day to complete it. So there is going to be one question that requires you to submit a picture of a tree diagram, and we're going to look at that together in a second. I really think it's just a matter of uploading a photo, so it shouldn't be too bad. But again, if you get stuck and if there's any problems and you can't upload the image, it's don't stress about it. Just email it to me or something. Just get that picture to me somehow. You can send it to me on Remind too. That works. As long as I get the photo so I can give you your points, you'll be good to go. But I'll review that with you in just a second. And at the end of the day, just do your best. Okay, that's really all I can ask for. All I can ask is that you do the best that you can on the quiz, that you do your assignments to prepare yourselves, and that everything you do honestly. Okay, you make sure it's your own work. And I am a happy teacher. So let's check out the test, okay? So over here is period 4's materials page, okay, where usually you land when you click on our class website or class Schoology page. And your quiz is going to be all the way down here. It's not posted yet, so that's why it's kind of grayed out. And let's preview this thing together, okay? So as always, you'll get a little message from us. Again, just reminding you that you have the day to submit the test once it starts, okay? So that doesn't mean that it's due today. It means that once you click start new attempt, the timer will begin. Okay, so whenever you feel ready to sit down and take this test, you know, you got your notes in order, you've got yourself a reference sheet with some formulas, stuff like that, then you come in and you click start new attempt. Okay. I'll have this video linked down here in case you'd like to find it there and access it and watch it one more time. But once you feel ready, you go ahead and start, okay? Okay, so here we are. Here's a preview of the test once we've started our attempt. Notice that I've got a timer down here telling me how much time is left for this assessment. I've got plenty of time. That's a lot of minutes. But again, if I wanted to take a break or take a minute to go through my notes, I don't want you to feel stressed or rushed to complete this test. Our first question here asks you to make a tree diagram. Okay, drawing it on the computer, drawing it on paper, doesn't make a difference to me as long as it is accurate. Okay, so choose the format that you would like to draw this tree diagram in. And then I want you to submit it here. This is where it would be the easiest for all of us involved. But again, if you have any trouble with this, you can email it to me or text it to me on Remind. Down here in your text box, there is an option for image and media. When you click on that, it'll take you to your computer folders and you can select a photo to upload. Okay, and it'll just pop up here and you'll be good to go. Okay, so just upload a photo of your tree diagram by, again, pressing the image/media button. Okay, the rest of the test I think is pretty straightforward. Here again, they offer bears, except this time they decide to include 10 different colors. Okay, again, each with or without a balloon. So you can type here to enter numbers. It'll fill in the blank for you there with the units. So go ahead and do that. Question 3 says that they decide to add a new Teddy style and they add Teddy Tigers. So take that into consideration. And for an extra point here, just so you know, an extra point is like 5 to 10% of your grade. Some extra points here. Let me know how you arrived at your answer based on the material you deduced in question 2. Okay, so that's the first one. When you're done, you'll go on to the next page and you'll have a new scenario about the Esposito family who is trying to paint their house. Because they're trying to paint their house, different colors. What happens if we want a different color for the house body, the shutters, and then the trim? We're going to decide which ones are permutations and combinations. So that's the multiple choice happening there. And finally, this is our last page. Okay, notice up here, page 3 of 3. We've got a swim team, 25 swimmers, and we're trying to pick 4 students for a relay. So again, we've got to fill in the blank problem here, and then fill in the blank problem there. All right, once you're done, you're going to click Review Answers. You can review the whole thing just to make sure everything is filled in. So this little yellow triangle would kind of make me stressed. I'll have to go back and make sure I put an answer in there. But as long as everything's filled in, you are special and you actually have a submit button. I don't, because I'm the teacher. But you can go ahead and submit and you'll be good to go. And I'll make sure to grade those on the daily, whoever submits them, so I can get you your score back as quickly as possible. Now, once the test is over, you won't have the option to go back and look at it and look at which ones you got wrong, unfortunately, because a lot of people are still going to be trying to submit the test. So if you're really, really curious about which parts you did correct and which parts you needed help on still, you can always email me and we can go over your test together. That's definitely an option. But getting to see answers at the end, it isn't going to happen. So it's not that it's glitching. It's just that I have to keep things locked up until everybody takes the test. Okay, so again, take your time with this. Don't feel rushed. Don't feel pressured into taking it today because that's when it's been assigned. Make sure that you're mastering the material before you take the test, only because, you know, TCMS policy says you can only do it once. So again, I'm always here for you. If you've got questions, if you've got comments, you reach out to me. I will answer you. I hope that you're all doing well still. And I hope to speak to all of you soon. Try to make it to the Zooms. I miss you guys. Other than that, have a great rest of the week. Let me know if you need anything. Talk to you later. Bye-bye.